Meet C++, Java, and Python, three of today's most popular programming languages. On the surface, they may seem similar with their code and syntax, but behind the scenes, they operate very differently. Today, we're going under the hood to understand how these languages really work on a fundamental level. By exploring the key differences, we can appreciate the strength and the use cases of each. Hi everyone, I'm San, co-author of the best-selling system design interview books. Our goal is to make complex system design concepts easy to understand through clear animations and simple words. Let's get started. C++ is a compiled language. It begins its journey when the source code is sent to a compiler. The compiler meticulously analyzes the code and translates it into machine code, simple CPU instructions like add, move, and jump. The compiler outputs an executable file containing the machine code. This file is a standalone program that can be run on any compatible computer. This compiled nature makes C++ a great performer. It's often chosen for performance-sensitive tasks such as gaming or system-level programming. Compiled languages like C++, Go, and Rust take longer to compile initially, but then run very fast as the CPU doesn't need to interpret or just-in-time compile the code. Now let's look at Python, an interpreted language. It takes a different approach. Instead of compiling, Python sends its source code straight to the interpreter. This reads and executes the code on the fly. This process makes Python exceptionally flexible and user-friendly. It is ideal for situations where rapid development and readability are important. With its interpreted nature, Python is a favorite among data scientists, educators, and web developers. It's great for scripting, data analysis, and web development. However, this also means it's generally slower than compiled languages, as each line must be interpreted every time it's executed. Other popular interpreted languages include JavaScript, Ruby, and Perl. Then there's Java. Java uses a unique hybrid approach. First, Java's source code gets compiled into bytecode, which is then executed by the Java virtual machine. Here's the secret sauce. The JVM has a just-in-time compiler that dynamically converts performance-critical bytecode into optimized native machine code right before execution. This means Java code runs significantly faster than purely interpreted languages. One advantage of Java is its portability. Since the JVM is available on nearly every operating system, Java code can run on any device without recompilation. Java is also designed to be memory safe and secure, with features like automatic memory management. This makes it well suited for large, complex enterprise applications that demand stability, security, and scalability. Leading tech companies use Java to power critical systems. For example, Android apps are developed in Java, and Netflix uses Java across its infrastructure. Other bytecode language examples are C# and Kotlin. Thanks to advances like just-in-time compilation, the lines between interpreted and bytecode languages are blurring. Modern JavaScript engines use JIT to optimize performance. However, JavaScript still falls into the interpreted category. C++ offers raw performance, Python flexibility, and Java balances both. Understanding these core differences under the hood explain why these languages excel in different situations. If you like our videos, you might like our system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 600,000 readers. Subscribe at blog.bytego.com.